Today, let's look at this interesting problem regarding infinite nested radical. Here is the problem. Find the value of square root of 4 plus square root of 4 square plus square root of 4 cube plus square root of 4 to the power 4 plus square root of 4 to the power 5 and so on. Please have a good try before you look at the answer. Before we dive into solving this question, let's first examine a simple version of it. Imagine your task with finding the value of square root of 4 plus square root of 4 plus square root of 4 and the pattern keep going. This variation of the question simplifies the problem significantly. Now, let's denote this expression as x. Upon closer inspection, we notice that x squared equals to 4 plus x. This transforms our question into a quadratic form, x squared equals 4 plus x. Let's proceed to solve it. Rearranging the terms, we get x squared minus x equals 4. Now add 1 over 4 to both sides. Complete the square on the left hand side, we obtain x minus half square. And for right hand side, it is 17 over 4. Since x is positive, x minus half equals square root of 17 over 2, which means x equals 1 plus square root of 17 over 2, which is about 2.562. Using the method just now, we come up with this first attempt. So we let x to be this expression that we want to find. So x squared will equals 4 plus square root of 4 squared plus square root of 4 cubed plus square root of 4 to the power 4 and so on. However, the square root on the right hand side cannot be rewritten in terms of x, which means that this attempt failed. Let's start with the second attempt. We can try to approximate this term by looking at term by term. First, we look at square root of 4, which is equals to, and the second term that we want to consider is square root of 4 plus square root of 4 square. And obviously, this is less than square root of 4 plus square root of 5 square. This equals 3. Now, the third term that we want to consider is square root of 4 plus square root of 4 square plus square root of 4 power 3. 4 power 3 is 64. But we can write the 64 as 8 square. Definitely, 8 square is less than 9 square. This means that the value of this expression is less than square root of 4 plus square root of 4 power 3 plus square root of 9 square. From the direct calculation, we know that the value of this term equals 3. So right now, we know that the first term equals 2, which is obviously less than 3. The second term also less than 3. The third term also less than 3. These give us some idea. Note that the square root of 4 power n equals to square root of 2 to the power n square, which is obviously less than square root of 2n plus 1 square, which equals to 2n plus 1. And also, 4 to the power n plus 2 to the power n plus 1 equals 2 to the power m square plus 2 times 2 to the power n plus 1. And this can be factorized as 2n plus 1 square. So we look at this term again. Square root of 4 equals to square root of 4 to the power 1. So using the first result that we have above, it is less than 2 to the power 1 plus 1, which equals to 3. For the second term, square root of 4 plus square root of 4 square is less than square root of 4 plus 2 to the power 2 plus 1. Using the second result that we obtained above, this expression is less than square root of 2 to the power 1 plus 1 square, which is again equals 3. And the third term is square root of 4 plus square root of 4 square plus square root of 4 power 3. Square root of 4 power 3 less than 2 to the power 3 plus 1. This combined with 4 square, we know that it will be less than 2 to the power 2 square. And using the above result again, we know that this expression again less than 3. So this suggests that each term in this sequence always less than 3. So meaning that it is bounded by 3. We suspect that this infinite nested radical is actually equals 3. So we note that 2 to the power n plus 1 is square root of 2 to the power n plus 1 square. Expand the square, we have 2 to the power n square plus 2 times 2 to the power n plus 1. And therefore this is square root of 4n plus 2 to the power n plus 1 plus 1. We have expression 2 to the power n plus 1. There's a similar expression between 2 to the power n plus 1 and 2 to the power n plus 1. So we can use this result and say that this expression is square root of 4n plus square root of 4 to the power n plus 1 plus 2 to the power n plus 2 plus 1. And using this result again, therefore we have square root of 4n plus square root of 4 to the power n plus 1 plus square root of 4 to the power n plus 2 plus 2 to the power n plus 3 plus 1. And this pattern will go on. Now using this result and let n equals 1, then we obtain that the value of this expression will equal to 2 to the power n plus 1, where n equals 1, and therefore this is 2 to the power 1 plus 1, and equals 3. So the answer for today's problem is 3. That's all for today's lesson. I hope you enjoyed the video. See you again next time. Bye bye.